Okay. So, good evening, everyone, and welcome to the Institution of Mechanical Engineers. Sorry for the slightly delayed start, and particularly to those who are joining us online. My name's Richard Osborne. I'm Global Technical Expert for Sustainable Engines at Ricardo. More importantly for this evening, I'm the current chair of the Powertrain Systems and Fuels Group, which has organised and sponsored this event. Motorsport is pioneering the use of sustainable fuels for internal combustion engines. Tonight we're going to hear perspectives from the premier racing competition, from a sustainable fuel producer, and from a race team and power unit producer. Each of our panelists is going to speak for 15 minutes, and then we'll take questions from the audience. And I think we're almost unique in the UK in being able to assemble today's panel, and you'll understand if I'm experiencing a degree of imposter syndrome. So first of all, I'm going to introduce Pat Symonds. Pat's presentation is entitled Formula One and Sustainable Fuels, The Journey So Far. So Pat started his career designing championship-winning production racing cars, and then he joined the Tolman F1 team, working with Ayrton Senna, amongst others. It was with Benetton and subsequently Renault that he achieved success, including 7 world championships, and he became technical director for Benetton and then the Renault Formula One team. In 2013, he became chief technical officer at Williams F1 team, during which time the team rose from 9th to 3rd in the World Championship. And in 2017, he joined Liberty Media as CTO to assist the FIA in the formulation of future F1 regulations. As well as conceptualizing the next generation of Formula One cars, he also led the technical sustainability program, including initiating the project to introduce sustainable fuels to Formula One. Pat is a visiting professor at Cranfield University, a fellow of Oxford University, a chartered engineer, and a fellow of both the IMechE and the Royal Aeronautical Society. So, Pat, the stage is yours.
Thank you very much. So, tonight we're going to hear about sustainable fuels from both the manufacturing point of view and the user point of view. But I hope in my short opening talk to give you some background as to why Formula One is adopting sustainable fuels and what our objectives are. We'll also discuss what some of our difficulties have been, but why, ultimately, we believe that this is the correct solution for motorsport and indeed some areas of mobility. Formula One is introducing a fully sustainable fuel for the 2026 season. We've been developing the regulations governing this fuel over a few years in cooperation with the suppliers of Formula One fuel, the manufacturers of Formula One power units, our technical partners at Aramco, and ours and the FIA's theoretical studies. Our aim has been to define regulations that would provide a fuel with high performance, but still based on EN 228 and so directly relevant to road car use. The fuel will be a drop-in fuel, such that it will be used in a race or a road engine with no physical modifications to the engine itself. In addition, we want to encourage research into different routes and methodologies to produce a fully sustainable fuel, and so we are defining the outcome that we expect rather than the process or methodology for arriving at that outcome. Now, many people think that synthetic fuels are something new. They're not. So before we begin talking about our journey, let's look at a little bit of history. 80 years ago, during the Second World War, the Germans, lacking access to oil supplies, started developing synthetic gasoline from coal. There were 2 basic types of fuel manufactured, B4, which was a standard fuel, and C3, which was the fuel for the high-performance fighters. The top illustration is taken from a German report of 1944 comparing C3 and B4 to both the available fuel and fuel upscaled by the DHD process, which could produce enriched fuels from any gasoline. It was, however, a long process requiring high pressures and temperatures, but was used to add a blend component to C3. Also shown at the top is ET110, which was the hydrogenated fraction, which, when a small amount of tetraethyl lead was added, produced a 115 octane fuel. Most of the German fuel was actually produced by hydrogenization of coal, a process known as Bergius direct liquefaction, rather than the more well-known Fischer-Tropsch process. The graphs show the NOx sensitivity at various values of lambda and show that upscaled synthesized fuels can be pretty performant. More recently, Sasol were producing racing fuels for both Jordan and Arrows using the Fischer-Tropsch process, again through political expediency, as Sasol, being a South African company during the times of sanctions, had similar problems to those of Germany in the Second World War in terms of obtaining crude oil, and so produced fuel from coal, which the country was rich in. I was told some time ago by an engineer from Cosworth that this fuel outperformed the contemporary fuels which came from crude oil. Our journey, however, started with a different agenda. I joined Formula One, the commercial rights holder of the sport, in 2017. We examined many aspects that Formula One needed for a healthy future. One of these was sustainability, and I suggested that we could both enhance our image and make a real contribution to society if we developed and used sustainable fuels in Formula One. As a mechanical engineer, I needed to revise and extend my school chemistry, but the more I got into the subject, the more I realised that this could be a viable parallel path to light vehicle electrification. So in 2018, we put together these high-level objectives for a sustainable fuel project. Fortuitously, to the end of 2018, we started talking to Aramco about a future partnership, and this actually came about in 2019 and helped greatly with our project. So let's look at these 5 objectives individually. We wanted to emphasise the sustainability message, and by this time people were starting to talk about sustainable fuels in motorsport. I think that when I started, very few people understood exactly what a sustainable fuel was, and I'd probably include myself in that. There was a lot of confusion, a lot of different terminology, and certainly there was some bad press about early generation biofuels. I was determined that if we were going to introduce sustainable fuels into Formula One, we had to do it correctly. That meant having full traceability and, of course, an available supply of sustainable molecules from which to synthesize the fuel. Early on, we could see that this was going to be difficult, and indeed now, when we're just 1 year away, or just over a year away from racing the fuel, there's still not an abundant supply. This was yet another reason not to rush into an early introduction of a product that would not stand up to scrutiny, and led us to conclude that an introduction in 2026 with a new power unit was the best way forward. In order to avoid accusations of greenwashing, it was important that our fuel really stretched the boundaries of possibility when it came to making a truly sustainable fuel. For this reason, I was adamant that we didn't introduce shortcuts like co-processing, which, even if it might ultimately be a good route to volume production, did not really push the oil companies to show the true potential of maximum carbon reduction. Even when it came to the denaturing of the ethanol in the fuel, I was insistent this was done in a sustainable method, much to the chagrin but the ultimate acceptance of the oil companies. With the confusing semantics surrounding the defining of non-fossil fuels, it was really important that we had a rigid definition of what we meant by sustainable fuel, and this slide shows where we ended up. Now, I don't expect you to read all 229 words of it, but it is available on the FIA website as part of the 2026 technical regulations. The regulations are intended to ensure that the fuel comprises solely of advanced sustainable components, and that they in turn are composed of certified compounds and refinery streams. The final blended fuel must achieve a greenhouse gas emission saving relative to fossil-derived fuels of at least that defined in the transport sector of the EU Renewable Energy Directive. In practice, we expect the GHG savings to be much greater than this. The GHG saving calculation takes into account any net carbon emissions from land use change, the energy used in harvesting and transporting the biomass, and the production and processing of the advanced sustainable component. In any process where sustainable energy is used, this must be surplus to local domestic requirements. I think we did a pretty good job, and I think in 2026 we can say with our hand on our hearts that the fuel in use in Formula One is as sustainable as the technology and the supply chain will allow. Our third objective is interesting in that it's the one aspect where we changed direction after the project started. Initially, I was very keen to show what could be done with a synthetic fuel if we co-optimised the fuel and the engine together. This would open many possibilities, not least of which would be extreme compression ratios and cylinder pressures with high attendant thermal efficiencies. As you'll know, even with a sophisticated combustion system on the current Formula One engines, performance is limited by knock. I felt we could lift this limitation significantly through a co-optimization process. After all, if you're going to synthesize a fuel with an open toolbox of molecular components, there's no need to just copy fossil-based fuels. However, as the project progressed and we involved the fuel companies more and more, and indeed our communications people in Formula One, it became apparent that demonstrating the use of a synthesized drop-in fuel would be much more useful, and at this stage, a better message. We therefore decided that the 2026 Formula One fuel should be an EN228 type fuel, equally capable of running in a Formula One engine or any one of the 1.4 billion internal combustion engine cars there will be on the road by 2030. Our fourth objective was to ensure that we didn't limit the technology used to make the fuel. I was very aware that European governments had dictated that solution to CO2 reduction mandated the adoption of electric vehicles, rather than seeking the opinion of those who may have proposed alternative or at least parallel solutions. It was important that we didn't make the same mistake and in fact encourage competition to produce a closely specified final product in the most efficient way possible. You'll have seen many diagrams like the one before you showing the many paths to the various forms of energy carriers. Even this simple diagram can have many subsets, and between ourselves and the FIA we produced a diagram much more complex than the one on the screen, and then tried hard to ensure that we hadn't unintentionally closed off any promising path. While it's difficult to quote as an efficiency, nature is really great, even if somewhat slow, at taking CO2 out of the air, taking the carbon to grow a plant and releasing the oxygen. If you look at the history of synthetic fuel production, you see many different efficiencies quoted in terms of EROI, or energy return on investment, from 62% for direct liquefaction of coal to 42% for biomass to liquid. ExxonMobil quote greater than 80% for fossil gasoline. If we're ever to approach this figure, we need not just an abundance of surplus renewable electricity, but also, and very importantly, the freedom of process to find the best solution. Now, much of what we talked about so far is philanthropic, but we must never forget that the mission statement of Formula One is to produce the greatest racing spectacle on the planet. We couldn't afford for the introduction of the new fuel to raise costs by a prohibitive amount, or more importantly, to allow one supplier and engine manufacturer to gain the dominant position, thereby ruining the concept of close racing. The cost question was difficult, as Formula One fuels are already blended in laboratory conditions, and they are therefore relatively costly. But the introduction of sustainable fuels had the potential to increase those costs significantly in the short term. One mitigation was to increase the oxygen limit in the fuel to around 7% by weight, which is roughly equivalent to E20. The fact that 20% of the volume of the fuel could now be a relatively cheap component, like ethanol, would assist in controlling the final price. The current cost of a barrel, which is 159 litres, of Brent crude is $70. Once that's refined, it equates to around $99 for a barrel of gasoline. Aramco estimate the current cost of a barrel of synthetic gasoline, made using carbon capture technology, is around $250 a barrel, so there's still some way to go. The need to keep the racing competitive and not detract from all that we achieved from the 2022 regulations required a more innovative approach. In fact, one as radical as the original mass flow limit that was introduced in 2014. Our approach was to replace the mass flow limit with an energy flow limit. The current regulations allow a mass flow of fuel of 100 kilograms an hour, which with an LHV of say 43 megajoules per kilogram equates to an energy flow of 4,300 megajoules an hour. In 2026, we're reducing this to 3,000 megajoules an hour. And our rationale is that any limitation on energy will encourage the quest for increased efficiency, just as it did in 2014. Of course, this means that we need to be able to determine the LHV of all the different fuels that will be used, and a lot of experimentation was done to find an accurate and yet simple way of doing this. It was found that by doing a detailed hydrocarbon analysis and determining the energy content of each of the components of the fuel, it gave an accurate, simple and repeatable way of achieving what was required. While discussing the policing of the new fuels, it's probably worth mentioning that a great deal of effort has gone into the traceability of each of the components in the fuel in order to ensure that we are indeed sustainable. This is being done by a company which is independent of the FIA and which each fuel supplier has to work with to get their fuel certified. So I hope this brief introduction to the thinking behind the 2026 Formula One fuel will have shown you that this is a very serious project that I and my colleagues truly believe in. We've been acutely aware that we may be accused of greenwashing, and therefore our approach has been rigorous. I also truly believe that by bringing to public attention the fact that internal combustion engines can run on fuels that ultimately could add no or at least minimal CO2 to the atmosphere provides a pragmatic approach to retaining the freedom that personal mobility gives us while limiting the damage to the planet. So I'll now hand you over to Paddy, who will discuss the process by which his company is producing a very impressive sustainable fuel.
Thank you very much, Pat. Right, I'm just now going to introduce our second speaker. So Paddy Lowe is founder and CEO of Zero Petroleum. Paddy is a graduate of Cambridge University and is widely recognised for his achievements as an innovator and technical director in Formula One. A score of 12 world championships and 158 race wins is amongst the very highest in the history of the sport, including leading the Mercedes team in 2016 to the most successful season ever recorded, 19 wins from 21 races. Paddy's capability in Formula One has now been translated to the world of sustainable energy with the company Zero Petroleum, which he founded in 2020. In 2021, he secured a Guinness World Record title of first aircraft powered by sustainable fuel. Paddy is a Fellow of the Royal Academy of Engineering and an Honorary Fellow of Sydney Sussex College, Cambridge. And the floor is yours, Paddy.
Thank you, Richard. Unfortunately, I have to correct one of those stats. Hal will share the pain. That record no longer stands as the Red Bull beat us more recently for the maximum races in a season. But we have got the best triple, actually, Hal, 2014 to 16, with 51 races out of 57. Not that I'm a statistician or anything, but anyway, but great to be here. Thank you so much, Richard. And I think it's a good opportunity. I'd like to thank some friends in the audience. We have actually Gavin from Intertek. Intertek has been a very supportive company to Zero from very early in its history, and in fact is an investor and ongoing technical partner, as they are also for the FIA. But also great friends from the RAC, Ben and Jeremy, and Hugh from Motorsport UK, and David Richards. All have been very helpful in our journey so far, now almost 5 years at Zero. And finally to Pat, actually, because Pat and I worked together for many years in Formula One. I'd say maybe not together, but in opposition. But actually, it was Pat who inspired me to the direction of sustainable fuels some years ago. So he was ahead of me on that. And I'd particularly like to congratulate him on the Formula One regulations, which I think are a fantastic example of leadership in this sector. As Pat said, there is a lot of confusion and indeed greenwash in the subject of sustainability and sustainable fuels, and it's very, very important if you're going to go on this journey to do it right. And I think what Formula One have defined as a set of regulations, I'm sure it required some very difficult negotiations with oil companies, etc., to get that over the line. But from our point of view, a very good set of regulations, very sound, which will drive all the right outcomes and behaviours. I don't know, again, if Hywel may agree. We'll find out in the next slot whether he likes the regulations as the recipient in terms of client, but from our point of view, in terms of producing fuels, it's a very exciting prospect. Just a reminder, what is a synthetic fuel? This is how we would draw the recipe, but effectively, if we start from the bottom, we're making green hydrogen from water using renewable electricity. So you'll have heard of green hydrogen. Actually, the vast bulk of the energy is going into that hydrogen, so it has to be renewable, can be of any type. The molecule then, hydrogen, we call that the energy molecule, and what it lacks is utility. Hydrogen, very, very difficult material. Interestingly, doesn't exist in biology in its raw form, so I think there's some significance in that. It's a very, very dangerous and low-density gas. But a great energy carrier. And when we bring in carbon on the top row, we turn that molecule into something that we can store and pipe and deliver and has very high density. The only energy format that has a higher density than that, really, that's around us would be uranium for nuclear fission. So, we're in a really good spot. And again, we see that in biology with all the hydrocarbons that are in use in plants and animals. And what we do is bring that together in the synthesis. In our case with Zero, our particular version of Fischer-Tropsch, which Pat mentioned is 100 years old, we call direct Fischer-Tropsch. And the reason essentially is that we are able to make a refinery grade fuel directly from our process. We don't have to go via any further downstream refining or blending process. So we can make directly a gasoline or a jet fuel or a diesel according to our choice. So a refinery grade set of molecules. And just a reminder, what are the real points of synthetic fuels? And I will distinguish here from a biofuel. Biofuel comes effectively from agricultural feedstocks. So it's an agricultural product, whether it's direct, like a sugar making alcohol in Brazil for many, many years, or a second generation, as is dictated in the Formula One regulations, which comes from the waste of a crop. Nevertheless, it's a limited feedstock and not one which will get cheaper. So we look here at where a synthetic comes in, which is an entirely industrially made fuel. So if you look at the recipe before, all of that is machinery. There is no feedstock other than air and water, which are around in the immediate environment. So we keep the energy density of the regular hydrocarbons. We're 100% fossil-free. We can eventually make fuels, in fact, we already do, that are better than the fossil equivalents. They will be cheaper, and I'll come on to that. And they can scale to all necessary demand within our current industrial civilization. So these are all critical components of synthetic fuels, and why we believe in Zero, this is the future to transform our entire industrial society. Just a quick point on energy density. We have a lot of talk about electrification and how great electric cars are. I do like electric cars, by the way, but energy density is a very, very critical parameter, particularly in mobility. Aircraft being the most obvious example, but even if you go to marine, shipping, and anything in between. Density is a killer if it's low. You're effectively taking profit because you're taking payload. And that may be less true of your personal transport, but it's true in almost all other vehicles. And the number there, a lithium battery would be 50 times lower energy density than an equivalent hydrocarbon liquid. And hydrogen sits somewhere in the middle, depending on the containment, but it will be at least 5 times heavier. And volume is another factor, by the way, not even mentioned, but again, very relevant in an aircraft, for instance. And now we come to cost. So let's have a look here. We're looking at time. We've got a big grey line along the bottom. That's generally the cost of fossil fuel, around about $1,000 a tonne. We have biofuels in green there. Can be 3 or 4 times the price of fossil. These are seen as biodiesels, or which may be a little bit cheaper than that, but particularly aviation fuels, what they call SAF, sustainable aviation fuel, are at these 3-4x to fossil prices. The orange is showing the evolution of synthetic fuels. It's a newer technology than biofuels, so that there is some lag. But the very important difference here, as a wholly industrial process, we will drive the cost down. And if you think that that's unbelievable, think again, think about all the examples in history. Think of the cost of a car, think of the cost of a phone, think of the cost of aviation, think of the cost even nearer to home of solar and wind energy, and how that 20 years ago was considered almost a plaything, a ridiculous idea. The cheapest power station you can build in most parts of the world now will be a solar or wind generation station, not a fossil fuel station. So we predict to get parity inside 10 years, and we think that will be a real game changer in all manner of effects. Honestly believe in 10, 20 years, face the choice, just like we've seen in wind and solar. Do I go and explore for new oil in a new license offshore? It will be 30 years before I monetize that oil, by the way, during which I'm sinking huge capital into a pit. Or will I go and build a synthetic fuel plant where I know I can have the fuel inside 2 years and it will be cheaper and better? I think that's a clear choice. And that is where the world will move. I hope you may recall me saying that when it comes to pass. So we think it's a really exciting point. And the last point is around scale. I know somebody already asked me that downstairs. If you want some simple numbers, 6% of Australia's land area, which is far less than the degree that is uninhabitable, as a solar farm would make all the fossil fuel we use today on Earth as synthetic. So that just gives you an idea. It's a big amount of land, big solar farm, but that's absolutely viable. And we won't see a reduction in the need for liquid fuels. We will see an increase. More people want to fly, more people want a higher standard of living, and they're going to get it. We just need to do it properly. So it is actually a capital challenge, this. We know how to do it. We just have to go and invest and build it. We effectively have to replace the entire upstream of the oil industry with synthetic plant. Just a quick one, what do we do at Zero? We're Formula One people, actually. We have a very Formula One mindset about how we develop. So it's not just me, there are about 20%, we're 60 people now, 20% of us come from Formula One. So we bring that spirit to what we're doing. We make, as I said, drop-in versions of the 3 major fuels, very high quality. To give the gasoline example, we ran actually just 2 weeks ago a back-to-back on dynamometer of an EN228 gasoline at RON 98. comparing to a standard Run 98 ethanol free, which is actually an Australian grade. And we had more power on the dyno without any adjustment whatsoever. So, that's the standard of gasoline that we've reached straight out of our process without any blending or downstream processing. We can also make a replica of Jet A1, which is a very sought-after set of molecules. Most of the sustainable aviation fuels that you see will only reach a 50% blend limit because they don't have the right molecules. And we've run lots of engines. I'm not going to go through all of them, but I think most interesting, we ran that McLaren, Cosworth-powered McLaren in the middle at the British Grand Prix in the historic sessions on our gasoline straight drop-in. Worked perfectly. This is just showing our technology. I'm not going to delve in the detail, but essentially the point is that we can make jet or diesel or gasoline with effectively the same equipment. So it gives us tremendous authority. And I think if I go into the gasoline, we're very proud of the platform in the sense of being able to make not only, say, an EN228 replica, but also to make some of the fuels that Pat talked about, these high-performance fuels, let's call it designer gasolines. So, the future of chemistry in this sector is incredibly exciting because these are completely designed fuels. Every molecule is designed. We're not dealing with what we happen to dig up from underground. Fully engineered fuels. I'll just give an example there. Shown across, these are showing the range of the 4 primary molecules within a gasoline, for instance. The paraffins, isoparaffins, these are chains or chains with branches, and then we move into circles with cycloparaffins, and then the unsaturated aromatics, which are the base, like a benzene or onwards. And our process, we can make all these different mixes between the two, which really emphasizes the point I was making around the tailoring that's possible with a chemistry. Effectively, we're gluing hydrogen and carbon together in any way we wish, and that's a tremendously powerful and exciting opportunity, particularly as we move into the subject of motor racing, which is where we're headed. I've given you a lot of background there. I need to bring it back to motor racing, and I'll do that in a minute. But just showing where we are, we're currently making 3 litres a day in our plant in Bicester, not the shopping end of town. And we'll be moving to about 40 litres a day in about 4 or 5 months within our building, and then we start moving outside the building up to this 500 litres a day in second quarter next year, and onwards from there to eventually very, very large scales indeed. So that's our journey at the moment. This is where we're at today. The main picture in the middle there, that's our currently running line or train, as we call it. That's the 3 litre a day train, and we'll be building towards the camera the larger 30-40 litre plant. We've made the place look very attractive because we see this as a showcase for this exciting new space. One of our team was down at Brooklands today talking. I think they said there were several hundred kids. This was organised by the RAF to introduce them to this subject, and it was, they said, incredibly exciting how excited the kids were about this sort of notion. And we find that we feel like evangelists because most people we meet have never heard of synthetic fuels. They have no idea you can make fuel rather than only dig it up out of the ground. So my last 2 slides, I hope I'm not squeezing Hal too much. Just, how do we bootstrap this industry? Because like anything new, initial cost is a challenge. In aviation, we get great political support. Aviation is the bad guy in the world. Everybody should stop flying, apparently. It's a sin. Obviously, they won't, but it does mean it gets a lot of political support around moving into sustainable fuels. Interestingly, there is a great recognition now in aviation that ESAF, which is technically what we call, is an electrically generated sustainable aviation fuel, that is to say, a synthetic, that is the pathway to scale and to low cost. That is now recognised. A year ago, it wasn't. A year before that, they wanted to build hydrogen aircraft. A year before that, they wanted to build electric aeroplanes. They've finally started to understand, which is really great news, that this is the answer. And governments are now providing very strong subsidies. The UK are mandating synthetic aviation fuel from 2028, actually, as a small blend, but with tremendous price support. So that's a really good manoeuvre. And we see the same across all of Europe. So that's good for aviation fuel. In terms of gasoline, it's slightly more difficult because you're supposed to electrify all your cars according to government. So they're not really giving much price support or mandates or so on. So we're relying a lot more on voluntary markets. That's to say people who will be willing to pay more to do the right thing. And that can be corporations as well as individuals, so high net worths with their expensive cars, or, as example, Formula One or other motor racing series, or events with classic cars and so on. We're seeing, that's where the initial support will come in terms of premiums. People who are less price sensitive than, what you would expect to see on the regular forecourt. So this will be a tremendously important market, and why we're so keen to work in motorsport, and that hooks me back into why we're here this evening. Motorsport will be a critical component of bringing this technology into circulation, bootstrapping, to get us onto that cost curve where we will adopt and bring it towards widespread use and eventually equivalence in cost to fossil fuels. That journey will start in motorsport, actually, even perhaps earlier than aviation. So at that point, I will hand over back to Richard. So thank you very much.
Thank you, Paddy. And I'll introduce our final speaker, Hywel Thomas, Managing Director of Mercedes AMG HPP. So with a mechanical engineering degree from Bath University, Hywel Thomas joined Perkins Engines and then Cosworth Racing. In 2004, he joined what became Mercedes AMG High Performance Powertrains, working initially as an engineer developing the F1 Mercedes V10 engine. Hywel has enjoyed a career of increasing engineering responsibility at HPP, which led to him being first chief engineer and latterly engineering director during the development and deployment of the hugely successful 2014 F1 hybrid power unit. Since June 2020, he's been managing director. During his time at Brixworth, Hywel has been part of the team which has contributed to 9 F1 Constructors' Championships and 9 Drivers' titles. So, Hywel, please take the stage.
Hello, everyone. It's an absolute privilege to be here, and a wonderful thing to be speaking after these two great engineers, motorsports legends, these guys, and somehow I've managed to find my way up the stage after them. So that doesn't sound like me, what was just described. I think I am most proud, actually, that I've been at Mercedes for 20 years, and I am still at heart an oily power unit engineer. loved being part of that. Those early days of trying to get V10s and V8s to run at 20,000 RPM and keep the valve train together. That was great fun. Anyway, it's a privilege to be here. Won't go on too much about that stuff. Let's talk about sustainable fuels. That's our factory. Grown a lot over the years, and we've developed a lot since 2004 when I joined, and we were then an engine company called High Performance Engines at various times, but it's truly a power unit company now. A lot more electrification, battery packs, motors, power electronics, and I think this journey in sustainable fuel is another obvious step for us to take in developing something that really can make a difference to the world. If you ever get asked, I would recommend not going last. You spend the whole time sitting there thinking, am I going to say anything that's been said before? Am I going to disagree with anything? And you've also got no time left. But anyway, here's the same wording that got put up earlier. How many words did you say there were? Too many. The very start of the 2026 project, it was always going to be about 100% sustainable fuel, as you said. It was one of the key aspects. And as has been said by others previously, I didn't know what sustainable fuel was. Didn't have a clue. Fortunately, this has been put together. Unlike previously, go on, read it. It's a long piece of wording, but it has to be. It's very clear, and actually, what Pat said is absolutely true. Formula One engineers, most engineers really, if you give them a regulation, the first thing they try and find is a loophole. They're Harry Houdinis, and we've got some of the best. So we absolutely have to have a very clear definition, otherwise we'll be trampling all over it, and I think that one's pretty decent. But when people ask me what does it really mean, I go for that. No dinosaurs have been hurt in the making of this fuel, and that does it for most people. They kind of understand what we mean then. But I think what was also done with the regulations, I feel like I'm tipping my hat too often in this direction. It wasn't about saying what we had to do. It wasn't saying it had to be an e-fuel. It wasn't saying it had to be a biomass fuel. There was a lot of, although that wording is quite a lot of words, there's a lot of different ways you can go about it. And I think that's pretty canny, because it's like you say, it's about the outcome. The outcome's no dinosaurs get hurt. But actually, it gave us the option and different ways of approaching the problem. I've quickly put that up there. It's a bit of a comparison between the 2022 regulations, which was the last kind of small change to the fuel regulations, in 2026. And a few reasons, which maybe you'll agree or disagree with me, but I think they were pretty similar to what you said earlier. Despite we saying it's 100% sustainable, it isn't quite. It's going to be 99%. There are some small elements that are in there that we need, and there was always a bit of a gimme for 1%. But being sustainable was the key purpose of the regulations. The energy flow that was mentioned earlier, we're transferring to that, and the E10 becoming probably an E20. You can use different oxygen if you want, but probably an E20. And as we said earlier, it makes it easy to get one of the components, basically, and cuts down the costs. But still gave us some freedom, because it could have just been an E20. And then we look at some of the other specifications of the fuel that we just didn't have previously in F1. So there's a maximum RON limit, there's a sensitivity limit, there's an LHV limit, and the volatility is far more tied down. And what that was all about, it's good, I think, again, we're agreeing, which is nice, is all about road relevance. The regulation format was derived from an FIA pouring sustainable petrol. So really it should be a sustainable pouring petrol. So the RON is a bit high, but these are, and the ethanol is probably a bit more than you'd have, but they're all completely doable things to get it into something that you can just pour in. So that's where we got to with the regulations. As I said, I'm an oily power unit manufacturer, not a fuel producer. And what we're trying to do is make a power unit with the most performance. And what that means is we need to think about the fuel that we're using, that we're creating with our partner, in our case Petronas, in complete combination to what the power unit's going to do, to what are the regulations in the power unit. So we couldn't really develop the power unit, and we couldn't develop the fuel without a real thought about what are the other combustion parameters in the engine. And there's quite a number of them that are changed. So again, as has been said previously, there's a reduction in the amount of fuel that's being run. It's about 75%, something like that. It's going to be about that sort of number. And that's a regulation fundamental. The compression ratio is going down. Not something we're particular fans of, I must admit, but there we are. But that's about road relevance and simplification. So one of the big things about the new regulations were we wanted to get some new players into the sport, which was successfully done, but they were very keen on making sure that the compression ratio was a sensible number and more in line with road car. We've got a boost pressure limit imposed upon us. I've got a pound bet. No, a pint. It's a pint, isn't it? I've got a pint of beer bet. Pat doesn't think we'll get anywhere near it. I'm not so sure, but we'll have to see where we get to in that first race. The MGUH, so the electric motor that was in the middle of the turbocharger. Really lovely piece of kit, absolutely gorgeous piece of kit. Didn't really become used in industry and was quite complicated, I suppose. And again, one of those ones that for sort of cost down, simplification, road relevance, we just had to take out of the regulations. We don't have a variable trumpet. The injector's mandated. The injector position's constrained. The compressor's constrained. The turbine's constrained. There's a lot of stuff put in to try and reduce differentiation. As was said earlier, the key thing for the sport is that we want close racing, and we don't want one power unit manufacturer doing better than all the others. So we'd like to reduce the possibility of that happening. When we say we don't want one power unit manufacturer to dominate, that isn't obviously true with the person stood here, but I get the point. And certainly the regulations are less free than they have been, and I'm sure will lead to less differentiation. So that's where that's the fuel regulations and the combustion engine regulations, particularly the combustion part of the regulations that we're working with, and we need to make that fuel and the PU sing together. Here's some fuel basics. I worry about this next couple of slides because I'm no fuel person, but if I look at the difference between pump fuel and F1 fuel, I think the main basis of a pump fuel is the cost. That's what people are talking about. That's what people are working on. There's a lot of constraint on it, volatility, RON, sensitivity, the sort of things that we've now added to the 26 fuel. But basically, the cheaper you can make it, the less refined you can make it, the better it is. And that's why you end up with a fuel which has probably got greater than 150 components in it. If I look at current F1 fuels, and this is the current situation I've got on this slide, it's all about performance. We don't really care about the cost. In fact, we know from long experience what are the components within a fuel that really the combustion engine likes. What does it enjoy burning and what doesn't it enjoy burning? And because cost isn't really a limitation, all we want in the fuel are things that the combustion engine loves burning. We don't want any passengers, especially with only the sort of the limitation that it's only 100 kilograms an hour. So it's a volume. You don't want any of that volume made up of a passenger. So we end up with fuels made up of probably less than 10 individual components, certainly the bulk fuel. There's a regulation, which is the 530 regulation, which I always get into a muddle when I try to explain it. But it basically means, I've managed to get in a muddle again. 30% of the fuel has to be, any component of less than 5% has to make up 30% of the fuel. Is that one right? It's about that. It means you're going to end up with six components or 7 or 8, that sort of number. You just end up with very few components because that's what you want. So how does that compare with sustainable fuels? Well, when we started the project, there were sustainable fuels available, but they were very much in that sort of available, as has again been mentioned previously, the availability of components was actually pretty poor. So the available AS fuels when we started were made again of many components. The constraints on it were very much to be a pump fuel. And if we're honest, when we tried the performance of those sorts of fuels, it was terrible. It really was. The F1 engine didn't like that at all. And again, it's because of those passengers and the refinery and the amount of the refinement that's done on the fuel. So what's the AS F1 fuel going to look like? Well, we're far more about performance, that's for sure. But there is still a big part of it that's about availability. These components are not as available as you would want them. You can't look at the 7 or 8 components that we had and necessarily just make a fuel exactly the same as that. And anyway, we can't, because we've got the volatility rules, the RON rules, the sensitivity rules, and actually that means that we can't get away with some of the fuels that we had previously. And it's put us in quite a tight box, I'd say. I'm sure everyone, as I said with some of the PU regulations, everyone will be desperately trying to pop out of that box to get a performance advantage, but it's quite a tight box. So if I look now at what that means for the engine, I wanted to just put this up there, which is a bit of a description about how we do engine development. This is 10 years ago, let's say, probably in the lead up to 2014. There's a nice learning loop in the middle of that. You have an idea, you do some design, you do some make, you do some tests, you have a conclusion, you pop it back in and try and think, what's the idea? And off the top of that, one of the things we did was a lot of fuel development, and another thing we did was a lot of combustion simulation. But they were pretty separate. There was a generic fuel model that we used, but it wasn't something that was able to drive the fuel development. So we'd have combustion ideas, we'd have fuel ideas, we'd put them together, we'd get around the loop. It would take quite a long time. That's probably where we were 10 years ago. But I'd say today, the way that the development's done is far more together. You can say there's almost 2 loops there now, really. There's the combustion development and the fuel development and the combustion simulation. Everything we do now, every idea we have will go through that combustion simulation. And we can plug in different molecules, we can plug in different fuels, and we can really do that work without having to go into the sort of more time-consuming design, make, test, conclude. Of course, it's not perfect. We're not suggesting that the combustion simulation is. It's a really, really difficult skill, a really, really difficult problem. So we'll continue to put various things through, but it's a far, far different world than it was 10 years ago. And being able to do this sort of thing allows us to really develop an awful lot quicker and get through loops an awful lot quicker. And really it's helping us to understand what the available sustainable components are and how they work with the engine. I think I've been pretty swift, which is good news. Good news for everyone. I guess the conclusion is the PU is pretty agnostic to where the fuels come from. It doesn't care if a dinosaur's been hurt. It doesn't care where it's come from. It doesn't care if it's an e-fuel. It doesn't care if it's come from biomass or one of the other sources. It just cares if it makes performance. And that's what we're all about. Learning about the fuel, learning about those components, and getting that to work with the engine. And as has been pointed out to me a couple of times this evening, we're only about a year away now from making engines that will go to track test for the 2026 season. So things are coming around pretty quickly. What seemed like a long time ahead of us with much time to do many iterations is really coming home pretty quickly. And that is in all the aspects, but in particular the the sustainable fuel is a big topic of how we're going to get the capacity, how we're going to get the amount of fuel that we need. So how will that all play out in 12, 18 months' time when we hit the track? I think it's in Australia, probably the first race in 26. The wonderful thing about sport and about motorsport is we don't know. We don't know how it's going to play out. We think we're doing okay, but there are several other factories that I'm sure think they're doing okay as well. So it's a fantastic opportunity that we've got. The sustainable fuel makes a real difference, and if we're going to be able to show that at the highest level of motorsport you can use a sustainable fuel, and that is what we are going to be able to show, then it really will be able to potentially show the world what can be done. And I think I'll leave it there. Is that right?
Right, thank you very much to all of our speakers. We are going to finish on time at 8:30, but we still have over 20 minutes for Q&A. So can I ask everyone to come up and sit on the stage? We're going to have some roving mics, and we also may have some questions online as well. I'm not going to sort of stage manage the discussion. I'd want to just encourage genuine questions from the audience, but I will take the privilege of asking the first question, which is, how do you think what you've talked about transfers from motorsport and Formula One specifically to wider road transport, and what are the problems? So I'd probably be interested in anyone's views on that, but anyone like to go first?
I can start. I think a little bit what I said towards the end of that presentation, what we're going to be able to demonstrate is that it can work, and a sustainable fuel can be a performant fuel, and it can have that opportunity to change something. But absolutely, from the motorsport perspective, it's that selling of the story, selling of what can happen. We're not going to be able to answer the questions of how do you create the volume, and I think that's something that's probably more at Paddy's end of the table, of how on earth do you turn that into a product that can operate in the very many fuel cars that are still going to be out there.
I'd agree. I mean, I think it's about bringing that message. I talked earlier about having to be an evangelist. This is just about communication, showing what's possible. And that will drive, two important things. It drives policy, so that's government understanding and making decisions, and it drives investment, so that's confidence coming from the people with the capital. And we find there's incredibly low level of knowledge in both of those communities actually around what can be done. And I think Formula One is a fantastic platform, and it's shown itself in other spheres in all its history, its ability to communicate the possible. I think batteries was a great example. I mean, Hywel and I and Pat worked in the period of bringing in hybrids, so that is bringing in batteries to Formula One in 2009 with the first KERS systems. And that's where we showed that a battery could be a very small size battery, could have incredible power density, energy density, in a way that was, prior to that, unimaginable. I mean, phones were the type of battery that you had before that, not batteries that would run and deliver 120 horsepower or more. That was another prior example, and it drove fantastic investment into battery technology.
I think probably what I'd add to that is that last year, Felix Leach, who's in our audience, and myself made quite a presentation to the European Parliament, putting forward the case for these sorts of sustainable fuels. With, I think, some success, and until then we really hadn't seen much at all. Everything was about electrification. And they moved with an amendment to the European regulations to allow RFMBOs, renewable fuels of non-biological origin. Now that's a step. It's not really what we're after because, again, it's closing things down to a single source. And everything we've tried to do in Formula One is to say, what is the best source? Is it RFMBOs? Is it making from waste? Is it methanol to gasoline? So many different ways of doing this. We want an open competition and let the best man win. And that's what it's about, I think. But we are getting there. At least now we've seen that little chink in the armour. I think when you couple that with what's been happening in the last few months with the questioning again of whether full electrification is the right way to go, then couple that with 2026 when people are turning on their televisions and they're saying, oh, I didn't know you could do that, then maybe we'll get somewhere.
Great, thank you. Okay, I'd like to take the next question from the floor if we can. We have some good questions online, but let's start in the hall. So we have one just right in the middle here. If you can just give your name and affiliation and then the question.
Thank you. My name's Colin Winslet. I'm retired now, but I worked at Ricardo and at Delphi Fuel Systems. Hywel, in your presentation, I was interested to see that the 2026 regulations include dimensional constraints on injector location, compression ratio, turbine, and so on. Do you think that constrains the ability to further develop combustion systems to take advantage of these new fuels? And is that a mistake?
I would say that it certainly constrains us, for sure. I'm not sure it's a mistake. I mean, some of those are very light constraints. Some of them are, the injector has to be, it has to be, on the side of the combustion chamber, which is where everyone's had it for the last X number of years anyway. So it does constrain us, and it does stop us looking at different things. But again, a big part of the regulation was to narrow it down, to allow other competitors to join, to keep the costs down, and really, in doing so, I guess we're spending more of our time looking at sustainable fuels and more of our time looking at how do we develop those instead of perhaps some of the other things we would do. So I'm not sure it's a mistake, but certainly it's cut down the number of avenues of pleasure that we take ourselves down.
Great, thank you. I'll take one online and then we'll come back to the room. So one question that's come in from Tim Lake. So can you comment on any differences seen in abnormal combustion effects for different blends, and are you able to model them? So I think that's referring to NOx pre-ignition, low-speed pre-ignition.
I wouldn't. I mean, the combustion that we have, and the combustion modelling and the combustion measurements that we have, we always find anomalies. We always find strange things, but we're all very normally changing lots of things. I wouldn't say that there's been a particularly surprising or different outcome from any of the sustainable fuels. As I say, the engine's pretty agnostic. It doesn't really care where the carbons come from. So as long as we're coming up with a relatively refined product, I don't think we found particular oddities. In terms of our ability to model things like NOx, yeah, it's really hard. It's really, really hard. It's really at the edges of what we can do. But it gives us an indication. It gives us a first look and allows us to do some screening ahead of getting into single cylinder work, where for some of those very complex processes, we are reliant on the engine to tell us.
Great, thank you. Okay, let's see if there's another question in the room. There's one right in the middle. Felix.
Felix Leach, University of Oxford. Thanks for a really interesting set of presentations. We're in Westminster, policymakers are just around the corner. What one policy measure would you advocate for to come out of Westminster to help support the development of these fuels and this technology?
I'll start. I think that, again, what I really tried to do in writing these regulations was to give us multiple pathways rather than dictating how things should be done. I think that I mentioned it in my talk that one of the things we learned was that governments had decided that electrification was the answer. Now I can understand part of it. Dieselgate has hurt us all, and that's resonated with the policymakers. It's led to a lack of trust in the motor industry and therefore the ability to dictate more. So if I was to ask for one thing, it would be to open up the avenues. So, for example, as we bring in sustainable fuels, don't limit them to RFMBOs, allow other methodologies as well. But above all, I think what I'd like to see is a roadmap for blending. We put E5 in fuels many years ago, some years ago. Went to E10 a couple of years ago. I'd really like to see some future regulations that took us up to E10, E15 plus, let's say, 5% of a sustainable fuel, moving up to 10%, etc., etc. And I guess that's the thing I'd really like to see, because that would then, just as it forced the fuel manufacturers and the vehicle manufacturers to make the E10, approve the E10 in the engines, it will do the same thing.
Yeah, I think I would like to see a lot more focus on investing in UK technology. Obviously, maybe I would say that because that's who we are, but we see an incredible imbalance. There's been a huge support for development of batteries, for sake of example, and almost anything else other than sustainable fuels has received incredible support in terms of the technology, not just the production. I think the UK has the opportunity to be a world leader in the technology by which we move to net zero across the entire planet, and the export of that technology to the entire planet, not just the direct carbon credit of just the UK, which is really a very parochial matter, really. And we see, for instance, in solar and wind power, which have really taken off in a way nobody expected. And Britain has been fantastic at procurement of capacity, but we're not building that technology. It's all foreign material. So I think that's a big miss. And I think that could be done differently in the world of sustainable fuels if they would support that.
How do you want to add anything?
I can't add a great deal. I guess I can echo some of Paddy's thoughts, though, that the numbers of grants, the amount of government money that is available, it is high for a lot of the electrical vehicle technologies, and it's very welcome. And things like the R&D tax credits, really, really welcome, and it does allow us to be competitive against other countries. And I think if moving some of that towards sustainability and sustainable fuels would certainly help.
I think actually, by the way, the other thing governments could do is actually make sure their own consumptions are, they can be the first consumer of these more sustainable products from their own consumption, and there's really none of that going on.
There's a question online which is kind of related, so I'll just give that to kind of continue the same theme. So the question is, will F1 engage with ACEA and other automotive industry and government bodies to drive a science-led, technology-agnostic campaign to ensure the wider public and policymakers understand the true impacts of sustainable fuels? ability to decarbonise transport. I don't know. I'm interested in to see whether you think that's F1's role is to do that kind of thing, or I mean, it sounds like you already are doing that.
Exactly,
Yeah.
we certainly are. I mean, we haven't just engaged with the European government. We've engaged with people like the E-Fuels Alliance, Fuels Europe. As I said in my presentation, I'm a mechanical engineer. I had to learn a bit of chemistry to do this, and therefore, I look for help wherever I could find it. And so we have engaged with these organisations. We've learned a lot from them. We've understood a lot of where the problems lie, and I think that we need to continue to engage and to support.
Great, thank you. Let's just see if there's another question in the room. Yeah, Roger.
Roger Cracknell from Shell. Thank you all for really excellent presentations. I was going to ask you about local emissions from Formula One going forward, because obviously the 2026 regulations will obviously insist on advanced sustainable fuels. But obviously, air quality still, for better or for worse, is a driver for regulations. And we're seeing Euro 7, which is supposed to be the sort of final emissions limit. But do you see this also becoming important within F1 going forward?
Can I answer? I think that's a great question, because at the start of this project, I was very, very keen to introduce some emission regulations. I mean, it's no secret that our engines are not very good on NOx. What I didn't want to do was to have regulations that really just looked at tailpipe and therefore forced the teams into producing the most expensive and the most lightweight after treatments that I didn't think would contribute anything. What I really wanted to do was see what we could do to reduce the out-of-engine emissions. I have to say we got beaten down with that one, and I think it's a shame, because I think it's an important aspect.
I feel like I got told off then.
I didn't say who we got beaten down by.
I suppose the difficulty we always see with things like that is how do you do the testing, and how do you really test what's going around the circuit, and you can almost make a whole industry out of that, which is part of the reason why we're not always such fans of things. I think the other part of the regulations in 26, of course, is that it's going to be a pretty much 50-50 electric vehicle and 50-50 sustainable fuel. So I guess there's a little bit of working towards some of the air quality and that side of it. But I do think there is an underlying issue where people will think of sustainable fuels and will, perhaps I'm being unfair, but in some of the wider public will think that is already a clean fuel. And I think that's a problem that we might bump up against.
Okay. So a question that's come online, which is on a bit of a different angle, is: will there be a need for new skills or additional training for performance engineers to work effectively with sustainable fuels? Just wonder what you think about that.
I think we already have, certainly in our company, and I'm sure other places as well, a number of the engineers who are working within the combustion team have always been perhaps not experts in fuel formulation, but certainly experts on the PU side of fuel. And I think they've risen to the fore a little bit with this set of regulations, which is nice for them. But I think we already had those sort of skills. And really, once we've got out of the creation of the sustainable fuel and the matching of the engine, sort of downstream of that, it's a poor in fuel. So people don't really, people, the performance engineers, don't actually have to worry about it. They're also agnostic. They don't care where the carbon came from. So there is a proportion of the business that's changed to do that and will have developed. But thanks to it being a poor in fuel, not as much as we might expect.
I think I'd take a more holistic view of it. The fact is that the 2026 regulations are energy sparse. It's a fact. When we conceived the 2026 regulations, we wanted front axle energy recovery to replace the MGUH. Again, we got beaten down with it, and that disappeared. And what that meant was that by dropping to 3,000 megajoules an hour of energy flow, even though we've increased the recovery now, there's a 250 kilowatt recovery motor, you're still energy sparse. So I think that a great deal of performance will come about from how you use that energy, particularly as we've also got rid of the DRS, the drag reduction system, and we're now giving an energy boost as an overtake opportunity. So how that is used, I think, will be very good, particularly if it ends up, as I would like it to be, with limited use of that energy boost, rather than DRS, which is automatic. If you're within 1 second, the wing feathers. I'd much rather it became a tactical use, and therefore you had to think about it. And that's going to stretch the performance engineers a little bit, I think.
Great. Okay, that's brought us to the end of our time slot. I'm sorry for the people online that we weren't able to use all of the questions. I'd like to thank John Williams, who came up with the idea for this event and made contact with the speakers. And I'd like to thank all of the speakers again. Thank you.